Hello and welcome to Scripting for Artists. My name is Sybren, and in this episode we'll visit a topic that many of you have asked for, user interfaces. In the previous videos we created our own operator and then turned it into an add-on. The basics of creating your own user interface in Blender is pretty much the same. You create a class, you add some properties to it, you add a function to it, and then you register the thing. So in this video we will look at the following. We'll be finding existing UI code. So if you're wondering how did they do it, after this you'll know where to find it. We'll look at the ingredients of a panel before making our own monkey grid panel, of course. What else? We'll be adding operator buttons to the panel and then tweaking the layout a little bit. Then we'll add scene and object properties to it, and we'll also look at conditional drawing, because sometimes there is no active object, so you won't be able to draw properties from the active object. And finally, we'll look at adding your own operators to existing menus in Blender. Before we make your own, let's take a look at existing panels in Blender. In the 3D viewport, press N to show the panels, and then let's look at the 3D cursor panel. Right-click and choose Edit Source. If you don't see the Edit Source option, go to Preferences, Interface, and enable Developer Extras and Python Tooltips, and then it should show up. So let's see what happens if we click it. Blender now tells us here in the corner, but it's a bit far away because of my scaling. It tells us to go to a text editor, and there we should find the file with the source. But there's an easier way. If you split this window and make sure that there is a text editor right here, you can click Edit Source, and there you have the file. It will be opened for you and even scrolls to the right line. Now let's scroll through this and see what we can find. As we've seen with operators as a class, it has the same kind of naming. It has the category in capitals and then PT for panel type instead of operator type. And then in lowercase the rest of the identifier. And here you have the parent class. In this case it's panel and not operator. You would expect bpy.types.panel here instead of just panel, and we'll see why this is in a bit. Let's look for other commonalities first. We have BL-label, which is the panel's name in the user interface. And then we have a category, a region type, and a space type. The space type and region type define where in the user face it will show up. In this case, we're looking at 3D viewport, and region type is UI, which means it's right in the 3D viewport and not in a header or a footer. Then the category is view, which is the name of the tab here. And then we get to BL-label, which is the name of the panel. Where operators had an execute function that performs the task of the operator, here we have a draw function that draws the panel. The drawing itself is done through self.layout, which is a UI layout instance. And you can find this with help and then Python API reference and search for UI layout, one word. There you'll find the class definition with everything that is possible. In this video I will show you the basics though, and that will get you quite far already. Now let's go back to that class definition, because we saw that panel here, and this is a little bit different than we've seen before. As I said, you would have expected something like bpy.types.panel and not just panel, and this is because in this file it's imported in a different way. Let's scroll to the top, and here you can see from bpy.types import header, menu, and panel. And because of this, you can just type panel instead of bpy.types.panel, and it would refer to the same thing. Personally, I would say be very careful with imports like this. It can save you some typing, and that may sound like a good thing, but you will read code way more often than you write it. I would always optimize for code readability and understandability rather than saving a few seconds of keystrokes. The only time where I would use an import like this is where it is very clear what's going on. In this case, it's Blender's user interface definition, and there is only one header, there's only one menu, there's only one panel, and they always come from bpy.types. So in this case, I would find it acceptable. In general, though, I would avoid this and always use the full name of the thing so that once you see it, it's clear where it comes from. Now that is out of the way, let's just jump in and make our own panel for the monkey grid. Let's take a look at our add-ons code where we left off last time. So here we have the monkeygrid.py with the monkey grid operator class and the register and unregister functions. Now to this, we can add our monkey grid panel. So just like before, we create our class, we name it properly. I kept the category view 3D because it's a view 3D panel anyway. We have the PT, I called it monkey grid, and we extend bpy.types.panel. I just copied these values from the 3D cursor panel. I named the category monkeys so that we get our own little tab there, and I labeled it grid. And then the only thing that you really need to have is a draw function. For it to show up as a panel, it needs to have a draw function, even if that function does nothing. And because a function in Python always have to have something, I put pass here, which is Python code for don't do anything. Every code block after a colon is indented, and every indented block needs a little bit of text there in order to make sure that Python understands that it's indented in the first place. So that's why they have the pass keyword. Now the only thing that's left is to tell Blender that this class exists in the first place, which means registering it. So we can just copy the register and unregister class function calls and put in our new class. And that should be it. Let's go to Blender, see what happens. Now all we have to do is reload the script. So go to System, Reload Scripts, and you'll see monkeys pop up here. This route also gives you access to right-click and then add to quick favorites. So if you do that, then you can just press Q and reload scripts. It will give you a fast way to reload them. When we go to the monkeys tab, we can see that our grid panel is here. It doesn't contain anything yet. Of course, we don't draw anything there, but at least it shows up. So let's put a button there for the operator. Let's go back to the code. And here in draw, self.layout lets us draw things. And to draw an operator, you type operator and then you give the ID name of the operator you want to have there. Let's copy paste that in. Go to Blender, reload the script. And there you can see we have a monkey grid button in the grid panel and it actually works. To customize this button, there's a few possibilities and let's go take a look at them. First of all, we can change the text that is shown on the button. So let's call it the default grid because pressing this button will just give us the default properties. Save the file, go back to Blender, reload the scripts, and now it's called default grid. The nice thing is that if we search for the monkey grid, then it's still called monkey grid in the F3 panel because that is the name of the operator. It is just that on this particular spot in the user interface, we have a different text on the button. Finally, we can add an icon to it. And then we have to know the name of the icon. So you can either look at existing code and cheat off of that, or you can activate the icon viewer add-on. It's bundled with Blender, but not activated by default. And then in the Python console, you get this button called icon viewer. Then you can click on the icon that you want, say a monkey. This has copied it onto the clipboard. Paste it there, save, go back to Blender, reload the script, and there you have the icon. In the tooltip, you can also see the description, and you can see that it will actually call our operator with all the default parameters. Let's tweak this and make some buttons that use specific values for these parameters rather than the default. So again, we go back to the source. Let's copy this call. And instead of just having this, we can say props equals self.layout.operator, yada, yada, yada. Let's change this to big grid. Self.layout.operator is a function that returns something. And the thing that it returns represents the properties of our operator. So here we can say props dot, and let's take a look. We had count x, count y, and size. So here we can say props dot count x equals 10, and count y equals 10, and size equals 0.8. So let's save, go back to Blender, reload the script. We have a new button, big grid, and when you hover over it, you can see that it has different values for those parameters. Delete the monkeys. And if you click on big grid, automatically it will take those values, of course. Now, to top this off, we can also make a small grid, and then we have a few more buttons to play around with. So for the small grid, let's set count x is 1, count y is 1, and keep the size to the default, so we just don't mention it here. Save, back to Blender, reload, and then we have a small grid as well, which is of course just 1. But in the redo panel, we can extend this however we want. Now you can also see the value of being able to set the text on that button because it's all the same operator, but with different behaviors. Now there's one more thing. I don't like how these buttons are spaced so far apart from each other because they're basically doing the same thing. They're creating a monkey grid and they should really be grouped together. Fortunately, we can do this by laying them out in a column. And I can hear you ask, but Sybren, they are already in a column, so what are you on about? Well, a function to create a column has some parameters that we can use to influence the layout. So let's take a look at our code again. Right now, each operator is drawn by calling self.layout.operator, and we can change it. We can create a column first, And then instead of calling operator on self.layout, we call operator on call. Save the code, go back to Blender, reload the script, and you can see they're already squeezed together a little bit more. And we can go a little bit further, add align equals true here, and then they are exactly as I wanted them to be, nicely squeezed together. So beside the operators, you can also draw properties on a panel, and this can be pretty much any property that you want. So you could use it to group together these properties that are strewn throughout Blender's user interface, but you use a lot. So for your specific workflow, you can add them to your own panel and make your life a little bit easier. So let's take two properties, one a property of cycles, so let's say the number of viewport samples in cycles, and the other I want to have relative to the currently selected object. So let's draw the viewport visibility there. So one of the properties is this guy here, the number of viewport samples, and the other property that we want to add is this one here, disabling viewport. Before we go to the code, let's see what Blender already tells us. So you hover over the viewport property. There it says at the bottom of the tooltip, bpydata scene.cycles.preview samples. And this is almost what we want, but if we were to use this, we would hardcode the name scene in our script. So if we ever rename the scene, then our script is broken already. And also when you use multiple scenes, it also wouldn't work anymore. So rather than using this literally as it stands there, even though for this case it might work, we will use the context again and just get the current scene with context.scene. So the property that we want to show is actually context.scene.cycles.preview samples. Now let's go to the code. Let's add another column. And then we call call.prop to render the property for us. It takes minimum of 2 parameters. The first one is the thing that contains the property, and then it's the name of the property. So the thing that contains the property is context.scene.cycles, everything up to the last point, and then the name is preview samples. Let's save, go back to Blender, reload the script, and there you have it, preview samples 10. So we can change this, and you can see that here it changes as well, which indicates that we have the right property. So here you can also add these text and icon parameters. They work the same as with the operator call, so in order to keep this video a bit to the point, I'll leave that for you to toy with. Now let's take a look at the second property we wanted to add, which is a property of the active object. I want to be able to control the viewport visibility, so that is this guy over here. And there it says bpydata object Suzanne.hide viewport. And again, as with the scene, we don't want to do this specifically for Suzanne only. We want to do this for the currently active object, which means context.activeObject. So the property we're going for is context.activeObject.hide viewport. Let's just copy what we had. Change the thing that contains the property to context.activeObject and change the property name to hide viewport, and this should render that property. Let's take a look. Back at Blender, we reload, and there is the property that we wanted to have. Now let's see if it works. And there you go. It's working, but it's a bit weird because it disappears. And here it doesn't. So what's going on? It turns out when you hide an object, it's no longer active. So that means that context.activeObject becomes none instead of Suzanne. None doesn't have a property hide viewport, so our code is actually causing problems now. Let's take a look at the terminal where I started Blender, and here you see a rather cryptic error message. Here at the bottom is the terminal where I started Blender from, and it's complaining about the monkeygrid.py file, line 82, which is of course the call that we just added, and it says error with argument 1 data, so apparently this argument is called data. Function.data does not support a none assignment. It's a bit vague description, but it does match what I just said. The active object is none, and you cannot draw a property of nothing. So we have to add a little bit of a guard around this code to make it always work. We know that context.activeObject can become none, so let's check for it, and in that case, let's just add a label. Otherwise, we draw the property as we did before. Let's see how this works now. Reload the script. And there you have it. It says no active object instead of erroring out, and all the code will keep working. You could argue that this is a bit of a silly button because it only works once, and you would be right. But I wanted to have this example to show you how things can go wrong and how to resolve that. It's also a demonstration of one thing that I find quite important, and that is showing why something is not there. So rather than not drawing the property at all and just silently skipping over it, now we draw the text no active object, which indicates to whoever is using your code why the option is gone. I think that's quite important, so that's why I wanted to have this example here anyway, even though it's rather useless. You now know how to draw your own properties, so it's up to you to make it useful for your particular workflow. Before we end this video, I want to show you one more thing, which is adding operators to menus. Given what we've seen so far, this is rather easy, so this is why I kept it as the last step. Let's add our monkey grid operator to the mesh add menu. So here we have add, mesh, and it would be nice if underneath monkey there was a monkey grid. This means we have to add it to a menu, and there's a trick for that. I will show you, but first we have to know which menu it is. So you can hover here over add, and it shows view 3D empty add, and you probably already guessed empty stands for menu type. Now the thing is, submenus don't show this. See, you don't know what the mesh is. But we can look around in the Python console and see if we can find it anyway. It is a type, so it is part of bpy.types.view 3D empty, and let's see if we can find something. There you go, mesh add. So this is very likely to be our menu. Calling it here will just give an error, so let's not do that, but at least we have the name now. View 3D empty mesh add in bpy.types. So let's copy this and then go to the code. As you would have guessed it, we have to do something in the register and in the unregister functions. And this time it's quite different than what we've seen so far. First we have to make our own function that will draw whatever we want to add to the menu. So that looks something like this. A name that you can think of yourself, and again self, context. For now, let's put pass in there to make Python happy. And this function basically will be called after the draw function of that panel. So where our own panel has this draw function with self and context, this function will be called with the same self and the same context. So self will refer to that menu in our case. Now let's register and unregister this function. This is done by taking that bpy types view 3D yada 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 and saying dot append mesh add menu draw. The opposite is remove. So in the unregister, we remove mesh add menu draw. Now what to put in here? Well, that's the same as with a panel. We can just call self.layout.operator. Copy the ID of the operator, and this should work. Let's save and go back to Blender, reload the script, add mesh, and there we have a monkey grid. It doesn't have an icon yet, but now you know how to add one, so I'll leave that for you. Now you've seen how to add your own panel, how to add your own operators to existing menus, but most importantly, you've seen how to look at other code. So when you see something that's interesting, when you're wondering how did they do that, you can just right-click, edit source, and most of the user interface elements in Blender are written in Python, and then this just works. So this is it for this episode of Scripting for Artists. If you have any questions or remarks, please leave them in the comment below, and I will see you soon.